Are you able to see my screen? Not yet. Let's try. Can you see my screen now?
Yeah.
Okay, great. Thank you so much. Okay. So house rules are, you can see this, right? Okay, everybody remember. Because we are getting more and more students in our class, right? Okay, so we have to respect each other, not everybody is as chatty, so we have to be mindful about our responses, about how we like to actually communicate with each other. So what we do is we are going to type in the chat box, like Jakai actually responded when I asked, can you see my screen? He said, yeah. Okay, he typed in the chat box. Thank you. So today we are going to go through the previous questions first. Okay, now we actually finished this particular one. For those of you who did not see this question before because you are new, okay, or recently joined, you may take a quick screenshot, right? You can take a quick screenshot. Okay, what we were talking about in this particular question is about this person, Eugene. Eugene ate a meal of chicken rice. Okay, so we are supposed to complete the table to show the amount of digested food that actually leaves the gullet and the small intestine. Hold on, let me mute my phone. Okay, and the small intestine of Eugene's digestive system after the meal, right? So after the meal, you see, because some digestion takes place in the mouth. We all know this. Right? So there are some digested food leaving the mouth and then enter the gullet because no digestion takes place in the gullet, right? So it's still the same amount of digested food that is leaving the gullet and then going to the stomach. In the stomach, there's digestion taking place. Okay, so that's why the total amount of digested food that is leaving the stomach is also higher now, right? And then goes on to the small intestine. Okay, yeah, adding by 10, right, Giselle? Correct. So in the small intestine, okay, there is completion of digestion. Okay, so amount of digested food leaving the small intestine, okay, of course, is going to be highest, right? Okay, of course, 30 might not be the fixed number. You can have 32, 35. Yeah, just don't go too extreme. Don't give very big numbers. Gordon, can you type in the chat box instead? Okay, get used to that. Now, next part of the question, 8B. Inside the walls of the small intestine are finger-like structures as shown. You only see this black and white diagram. Okay, the colored one is what I just added in. Yeah, you can even see this kind of diagrams online. You just need to Google, okay? Google things like inside the walls of small intestines. You will see diagrams, yeah, such as the one I'm showing you over here. So this is exactly how it looks like on the inside. So explain how these finger-like structures affect the rate of absorption of digested food into the blood vessels. Right? So they want you to explain how this will affect. So you need to talk about this structure, talk about the structure, that's number one. Number two, how does it affect digestion? Or sorry, the absorption. Is it faster or slower, more or less? You have to comment on that also. Is it okay? Need to know this, huh? So check your answer. Did you answer it in this way? The finger-like structures provides a greater exposed surface area, and therefore absorption of the food, right, can actually be increased. No, those are not. Okay, Giselle, those are not. Okay, Giselle, that's actually what you find inside the small intestine. Small intestine, okay? You know where's the small intestine located? Yeah, good. Okay, later I will put this link into the chat box for you to watch the YouTube video after the lesson, not now. If I send it now, you're going to watch it now, I know. Okay, so you're going to watch it only after the lesson. I know you guys, okay? Now, next part. Part C now. How do blood vessels obtain and carry digested food to all parts of the body? How does it happen? Okay. Remember in the small intestine, the digestion is completed, right? So in the small intestine, it is also where the digested food actually goes into the bloodstream, right now. But how does it happen? You need to talk about how it actually goes into the wall of the intestine and then goes into the blood. How do you write it down? Okay, digested food is absorbed into the walls of the small intestine. Then after that, it's absorbed into the bloodstream. Okay, where blood is going to transport all these digested food to all parts of the body. Yeah, so I see Gordon also put down some inputs, right? It goes through the blood veins. No, don't mention blood veins. Okay, don't mention veins or arteries. Just talk about blood vessels. And then it is the blood that is carrying the digested food. Okay, got it? It is the blood that is carrying the digested food. Nutrients of the food are absorbed into the blood and are circulated to the body. Okay, Jokai, yep, the nutrients of the food are absorbed into the blood. Okay, and then you need to talk about, you say it's actually circulated to the body. You need to mention slightly more. Okay, the blood circulate to the rest of the body. Okay, bringing the digested food to all parts of the body. You need to add on. But your answer is good, okay? You said that it's absorbed into the blood, right? But you're missing out walls of the small intestine. That might be one thing they look out for. If this is a 1-mark question, you will get the marks. But if this is a 2-mark question, you need to elaborate a bit more, Jakai. Yeah, so you look at my answer here. This is the complete answer. This kind of answer will give you 2 full marks. Okay? So if you take a screenshot, also try to annotate on your own that this will be a 2-mark question and a 2-mark answer. Clear? Can I go on? Thank you. Now, this is about digestion of food in the human digestive system. So this person conducted an experiment. What is his aim? His aim is actually to find out, see the aim is written here. You may want to do this during the exam. That is to underline. Okay, to find out if the size of food affected how fast the food was being digested. That is his aim. So he wants to see if the food is actually in big size, big pieces. Okay, the size are big, right? Big pieces of food. All right, will it affect digestion? Will small pieces be better? So those are the questions that are running in his head. He needs to find an answer to that. So he carried out this experiment. What he did is, now he has all these food pieces, right? Look at the beakers. The first beaker has 1 big piece of food there. Second beaker, which is called beaker Y, okay, he cut the food into half, right? And then the third beaker, beaker Z, okay, now he has the food cut into 4 pieces. All of these food, right, they have the same mass. They are the same type of food. They have the same mass. The only difference is actually the size of the food pieces. Okay? Yes, good. Okay, good, Giselle. Now, so in the beaker, there is also same amount of digestive juice. Okay, so this is how he set up the entire experiment. 2 hours later, he measured the mass of the food pieces left in each beaker. Do you recall we did a similar question like this in that lesson? Yeah, and I told you one specific answer is extremely important. Later, I will highlight to you again. Okay, so can you explain why the mass of the food pieces in all the beaker decrease? Originally, they were all at 100 grams, right? After some time, like 2 hours, okay, in beaker X, 91 grams of food is left. Beaker Y, 77 grams of food is left, and then beaker Z, 52 grams of food is left. Okay, so Gordon typed in his answer. Thank you, Gordon. There was digestive juices in all the beakers, and the juices digested the food in each beaker. All right. Okay, I like your answer. The larger the amount of food, the larger. Be very careful, Gordon. Be very careful when you say the larger the amount of food. We're not talking about the amount here because the amount is the same. 100 grams each. Agree? So you can't say the larger the amount of food in this particular question. Okay, the amount is the same, it's only the sizes. You should talk about the sizes of the food pieces. Yeah, so the larger the food pieces, the longer the time it takes to digest the food. Can change that. Note that down. Yeah, so Jerkai said, because the digestive juice digested the food pieces. Right. Right? Good. Yeah, I can see all your inputs. Well done. I like all these answers. So now that Gordon showed me his answer, I can tell him exactly what has gone wrong. Agree? You must do likewise. All right? You must do likewise. So after you have practiced, right, today you still have to key in for these particular questions because I haven't seen your answers before. But in future, I can see all your answers that you key into the portal when you do the worksheet. Is that clear? Right? Given that, it doesn't show unattempted lah. I mean, some of you tried, but you said that it wasn't reflected. So we'll see how to improve the system, okay? Now, who else type in something? Okay. Do I call you Raiden or do I call you Yenden? Yenden.
Call me Raiden lah.
Okay. Yeah, don't unmute yourself. Okay. Raiden, Raiden, thumbs up. Okay, can. Good. Now we have Raiden here, right? We have Gordon, and then we have also Jaden. Nice. Okay, so you said, is it exposed surface area? You are right. Exposed surface area is the important thing I'm talking about, but not for this question. Not yet. Okay, not yet. But you're right. For this particular part, right, or digestion, exposed surface area is important. And as we go along this year, you will realize also a lot of things has got to do with exposed surface area. Okay? Not just this particular digestion chapter. Right, so we have the answer here. Digestive juice in the beakers digested the food pieces into simpler substances. Right? That's why the mass decreased. You don't understand how exposed surface area can be used in the human body. Of course it can. Yeah. So if you look this particular food pieces, right? Okay. Now you tell me, if it's this one piece, okay, since Gordon asked, right? So I think I will address it over here. Okay, Gordon said he doesn't understand how come the food pieces also involves exposed surface area. Now, Gordon, this is one piece. Imagine it's a cube. So if I were to draw a cube, it looks like this, right? How many sides does it have?
4.
4. Think again. How many sides total? I have the front here, back here, right? Left and right, up and down. Total?
6 sides.
6 sides. Okay. Only Gordon can unmute himself. Okay, I'm going to guide him along. Now, take a look at this. Okay, so if you have this cube, and then this is a 2 cm by 2 cm,